In this video, we're going to discuss the AI operations intents that are available in Ruckus AI. From the dashboard, we can see that we have 29 new intents with 10 intents that are currently active. I'm going to go ahead and click on the AI operations icon and jump right into our intent table with AI operations already filtered. There are 8 different AI operations intents. Previously, they were called AI operation recommendations, and the configurations that are automated within each intent are the same, but the UI has changed. Let's outline each of the intents and then take a look at one or two of them. The dynamic versus static channel capability intent is going to have administrators choose between automatic channel optimization using background scanning, which is going to allow IntentAI to select the best channel in the environment based on scanning of the wireless background. It's going to avoid any interference and change channels. The other option for this intent would be manual and static channel settings that are already configured. So basically, we are not going to enable any channel changing, and that's going to allow you to maintain stable and controlled network performance in those networks where the RF environment really isn't changing that much. The network efficiency versus stability on the 2.4 gigahertz radio intent will give the administrators the ability to decide between reductions in the background scan interval, which is going to increase the efficiency by allowing the Wi-Fi network to quickly adapt to changes in interference, or we can keep the background interval unchanged and have a more stable and predictable network. The next two intents deal with dynamic frequency selection, or DFS. If you currently weren't running DFS in your environment, you might see the expanded radar channels versus limited channel option intent. This is going to allow the administrators to choose between activating DFS to expand 5 gigahertz channel options, which is going to reduce the congestion and improve the overall network performance. Alternatively, they could keep DFS off to avoid interference with radar or weather systems, which is going to avoid any disruptions from channel switching when radar is detected. On the other hand, if you are using DFS in the network and Ruckus AI has determined that there have been radar events, you might see the radar interference versus optimal channel availability intent. This is going to allow the administrator to turn off DFS to avoid that radar interference. Likewise, if they wanted to go ahead and keep using DFS to get that optimized channel availability, they could do so. The client performance versus compatibility intent gives administrators the ability to choose to either enable band balancing or leave it disabled. Enabling band balancing attempts to optimize performance by spreading client connections across the 2.4 and 5 gigahertz radios, improving load distribution. Leaving band balancing disabled, on the other hand, will allow devices to connect to their preferred band and avoid potential compatibility issues. The distributed Wi-Fi load versus client stability intent allows administrators to enable load balancing, which evenly distributes client connections across access points in the network. This prevents specific APs from being overloaded while others remain underutilized, providing an efficient utilization of the network resources. Disabling load balancing prioritizes the network stability, ensuring consistent connectivity and reduces the risk of client disruptions from frequent reassignments. The secure AP firmware versus client device compatibility intent is all about AP firmware versioning. Applying this intent will ensure that the APs in the zone have the latest AP firmware. The benefit here is that the APs will have access to the latest software features, functionality, as well as security updates. However, newer AP firmware could present issues with older devices, and not choosing to implement this intent would allow the administrator to prioritize network stability and compatibility. The last intent that we're going to talk about is the optimize for 5 gigahertz radio versus longer range with 2.4 gigahertz. This allows the administrator to decide between optimizing for 5 gigahertz by decreasing the transmit power on the 2.4 gigahertz radio band. When the radio power is reduced, the 2.4 gigahertz range is also reduced, which can allow devices at a closer range to connect using the faster 5 gigahertz radios. Not choosing to lower the transmit power of 2.4 gigahertz will preserve that range, ensuring broader coverage and avoiding the loss of coverage from clients that are maybe near the edge. Back on our IntentAI table view, we can see that we are filtered for those AI operations intents, and our intent column lists many of the intents that we just reviewed. Selecting any of the particular intents is going to give you the ability to do a one-click optimization, or if this was an active intent, you could pause or resume it if it was already paused. We're going to go ahead and click Optimize and just take a look at what it's being presented. So again, we have the wizard here that gives us the introduction and summarizes what this intent is, which zone it's for, and when it was last updated. Choosing next is where we can actually set the intent. So in this case, we're talking about the 5 gigahertz radio optimization or longer range 2.4 gigahertz operations. If we chose to apply this intent, we would be doing a reduction of the transmit power on the 2.4 gigahertz radios. So we have the options of yes, we do want to apply the recommendation, or no, we do not want to apply the recommendation. If we were choosing yes, we would proceed and we would be able to set the time for the zone that we want to push that configuration change. We're going to go back and choose no and say, no, we actually don't want to reduce power on the 2.4 gigahertz radios. And when we choose next, you can see, hey, there's no date and time selection. That's because we're saying, hey, we don't want you to recommend reducing the 2.4 gigahertz power for this zone. And we don't want you to make this recommendation to us anymore. So if I was to go ahead and choose next, it's going to say, hey, IntentAI is going to cease the automated monitoring and change for this intent. We can go back and manually control it, or we can choose resume on this intent after we've made this selection. So if we don't want AI to recommend this to us anymore, we could choose no on that intent and we would be good to go. I'm going to go ahead and cancel this and jump back out to the table view. And what I want to take a look at next are intents that are actually already applied. After the intent has been scheduled and the configuration changes have been applied, it moves to an active status where Ruckus AI continuously monitors the intent against a specific KPI. Each of the KPIs that are monitoring vary between the intents, but we'll take a look at just a few of them. Coming down to this client performance versus compatibility intent, you can see that we have recommended to enable band balancing, and it is currently enabled. The KPI metric that we are monitoring for this is the percentage of clients on 2.4 gigahertz, which for this zone is currently 81%. The gray pill to the right of that number is representing a 4% increase versus the last configuration check for this. So again, when we say that this is being continuously monitored, that's what we mean. We can see we are 4% higher for this metric than we were in the last 24-hour check. We still get some details on why the recommendation was made, as well as some information on why this 81% may be as high as it is. It's saying some devices may experience compatibility issues or be forced to connect to less optimal bands. While that could be the case, this also could be a skewed representation based on the number of devices that are actually in this zone. If we only have a few devices in this zone and they are on 2.4 gigahertz currently, then yeah, this number is going to be much higher. So you have to kind of understand what it's being recommended, as well as be familiar with the zone and the devices that are in it. In this intent, we went ahead and optimized for that 5 gigahertz radio by decreasing the transmit power of the 2.4 gigahertz radio. And you can see the actual recommended versus the current adjustment that was made. We can see our session time for 2.4 gigahertz KPI, as well as a co-channel interference ratio KPI for this particular intent. We still see the why are we encouraging this recommendation, as well as the potential trade-off. And again, all of these recommendations have that status trail that we can look at to see when adjustments were made.